In this last lesson in trigonometry, we're going to look at applications of how we can use trigonometry in the real world. And one of those is something called bearings. Bearings measure angles in terms of compass directions. So this is really an application of where we can use trigonometry alongside geography. So there's two different ways you can look at bearings. Number one, cardinal directions. Cardinal directions mean your north, east, south, and west. So we look at this diagram right here. North is always to the top, east to the right, south down, and west to the left. Then when we talk about bearings, for instance, N30W, means we start at north, that's the first one, and go 30 degrees towards the second one. So in this diagram here, north 30 west would be right there. That's kind of handy because we know that all cardinal directions are 90 degrees apart. So if we had 30 on the top, we would also know we have 60 on the bottom. So just to try a second one, if we did S and we said 15E, we would start south, which is here. We would go 15 degrees towards the east, and there would be our angle. 15 inside on that way, or 85 degrees on this way. Sorry, 75 degrees, not 85. Have to add to 90. Okay, so that's one way of measuring bearings, cardinal directions. The second is in terms of a standard bearing. A standard bearing measures angles from 0, where 0 is north. And so when we do bearings, we go clockwise around. So every 90 degrees, 90, 180, 270, then back to 360 at the top again. Then if you're given an angle, such as 230, you know you've gone part way around the circle. You've gone 230 degrees around. Well, this is kind of handy because we know some things. We know that 180 is down here, so we've gone 50 degrees past 180, 50 more than 180, or we've gone 40 degrees less than 270. So again, we have two different angles. And if you want to try one, we could say, how about a bearing of 135? Where would that be? Well, it's between 90 and 180, so it's going to be somewhere this way. 135 is the entire angle. That's 45 more than this, so that's 45. Or it's 45 less than that. So again, you have two different angles. Okay, so that's our big idea. Let's try some questions. Again, the challenge here is going to be drawing our diagrams. So, first example, a sailboat on Lake Huron leaves Southampton and sails 20 degrees west of north for 20 kilometers. Same time, a fishing boat leaves Southampton and sails 30 degrees west of south for 15. At this point, how far apart are the boats, the nearest kilometer? So whenever we see bearings, we should think of a compass. On the compass, usually our starting point is right in the middle of it. That's where we're measuring things from. In this case, Southampton. So our sailboat. The sailboat sails 20 degrees west of north. In other words, it goes north, 20 west, west of north. So that would, oops, that's the east. Let's try the west. All right, so Southampton, we need to go north and then 20 to the west. So that's 20 degrees. And it did this for 20 kilometers. I'm just going to move my label of the S here, okay, on the other side. At the same time, a fishing boat leaves Southampton and sails 30 degrees west of south. In other words, south 30 west, west of south. Okay, so it's going to go this way. And again, it's 30 degrees to the west. And it went 15 kilometers. And we want to know how far apart are the two boats. So the general idea with these kinds of questions is we want to find the angle between the two boats, or between the two bearings, if you will. And we can find that because we know this whole distance is 180 degrees. It's 180 degrees because north is 0 and 180 is south. So if I have 20 at the top, and I have 30 at the bottom, I can take 180 and subtract the 20 and the 30 and get the bearing in between them of 150 degrees. Now I have an angle and two sides. Well, that's the cosine law question. And generally, most trig questions are cosine law questions. And just a reminder, cosine law where the big A's are the things that matter. In this case, little a and big A. So we'll have x squared equal 20 squared plus 15 squared minus 2. 20 times 15 times the cos of 150, the bearing between them. And put it all into our calculator at one time. We should get 1010.67 approximately. Remember, that's x squared, so let's square root it, and you should get 31.79. And now the question asks us how far apart are they to the nearest kilometer. So we're going to say the boats are approximately 32 kilometers apart. And there's a bearing question, okay? Using the idea of cardinal directions, north, east, south, and west. Let's try the next one. Two planes left Toronto at the same time. One traveled 450, with a bearing of 260, and the other 550 at a course of 320. I need a compass. I see some bearings in there. How far apart were the planes after 3 hours? Well, that sounds very similar to the previous question, except we've got planes instead of boats. So, let's give this a try. Our starting point is in the middle, at Toronto. One plane traveled on a course of 260. So 260 is not quite 270, it's just below it. It's like the measurement all the way around to here. That's 260. The second one traveled a course of 320. Well, 320 is more than 270, so it's up there somewhere. Again, that's the distance there. Now, if I put those two measurements back into my diagram, I had one of 260, and I have one of 320. Well, the difference between them will be the difference between my two bearings. In other words, 60 degrees in between them. One went 60 more than the other. That's kind of handy. I know the angle between them. I want to know how far apart they are. There's my x. But I want to know how far apart they are after 3 hours. So I'm not going to use the numbers 450 and 550. I'm going to have to figure out how far each plane traveled in 3 hours. So 3 times 450 for this one would be 1,350 kilometers. And 3 times 550 for the other one will give us 1,650 kilometers. And there's our problem again. Two sides and the angle between them. That looks just like the last question at this point. That's a cosine law. So x squared equals 1350 squared plus 1650 squared minus 2 times 1350 times 1650 times the cos of the angle. Again, the key is trying to get that angle. In this case, I could get it because I knew the two bearings. And I knew the difference between them. Okay, all into our calculator gives us a really big number, 2317500. And if I square root that, I get 1522.3. Okay, again, the question asks, how far apart are they to the nearest kilometer? So, after 3 hours, the planes are 1,522 kilometers apart. Okay, so we've done one question with cardinal directions. We're going to have to think about the idea of 90s and 180s to figure out your angle. This one does bearings, where you can figure out the difference between your two bearings, and I'll tell you your angle between them. But the problem solving is the same. They're both cosine law. So let's take a look at one that's not a cosine law question. Two forest fire towers, A and B, are 20.3 kilometers apart. The bearing from A to B is north 70 east. The ranger in each tower observes a fire and radios the fire's bearings from the tower. So it's one fire, and they're both looking at it. The bearing from tower A is north 25 east, from B, north 15 west. How far is the fire from each tower? So the challenge here is we're going to have to involve more than one compass, because we've got two starting points. We've got tower A and we've got tower B. And these two towers are not, they're different, right? They're two different places. So to do this question, I need two compasses. Now, these two compasses aren't side by side. I know that because it says the bearing from A to B is north 70 east. In other words, if this is A, to get to B, I have to go north and then 70 to the east. And then that would be tower B. And I'm going to spread them out just so it's a little more obvious here. Let's make this bigger. Okay. So there's A and there's B. Okay. From the towers, we're going to spot the fire. Okay, so from tower A, north 25 east. Okay, so north 25 east would be somewhere along that line, where the angle between them is 25 degrees, north and then towards the east. From B, the bearing is north 15 west. So B would have to be here, and it started north and it went 15 to the west. And if you notice way up here at the top in the words, they're going to meet somewhere. Well, that's got to be the fire. Okay. This one's a little bit trickier because we involve two compasses. The nice thing about two compasses, however, is that there's an idea that we can use to help us find angles. Because if you notice, because we have two compasses, we have more than the normal amount of angles involved here. Okay. To start with, let's go back to our first compass, the one at A. Okay. If we use the idea that the whole angle, the red angle, was 70 and the green one was 25, that means the part between them has to be the difference, 45 degrees. Okay. And the reason why is the red one is north 70 east, the green was north 25 east. Well, the difference between them has to be 45 degrees. That's kind of handy. Why is that handy? Well, if you look at questions involving two compasses, you actually have a Z pattern. Okay. A Z pattern happens when you have two parallel lines. So these two lines are parallel, and they're joined. Because the angle that we have has to be the same. So if that's 70, this is 70. And if that's 70, then the part on the inside has to be 20. And the part on the inside up here, again, has to add up to 90 degrees, right? Because you have a right angle there on the opposite side. So this has to be 75, which means that whole angle is 95. And if I use the 95 and the 45, I can figure out the angle at the top has to be 40. So when you're using two compasses, a key idea is to look for where is that Z pattern. Okay, we want to know in the question, how far is the fire from each tower? So we've got an X over here, and we've got ourselves a Y over here. We know the towers to start with are 20.3 kilometers apart. Well, that is a sine law question. So when you have two compasses, you're generally going to have to deal with the sine law. You have to match up things that go together. But to find the things that go together, you're going to have to look for that Z pattern somewhere in that picture. You have one of your homework that's going to give you a chance to practice this. Okay, so I know that for sure. I want to match up. What else do I know? I know that sine 95 goes with X. And I know that sine 45 goes with Y. Those are all the pairs in our picture. We got this one. We've got this one. So we're going to pick two at a time and solve these. Cross multiply. So X times sine 40 equals 20.3 times the sine 95. I want to divide out to get X by itself. And for x, you should get 31.5 kilometers. And we'll do the exact same thing to figure out y, but we'll cross out the one in the middle. So just use the outside ones. So y sine 40 equals 20.3 times the sine of 45. Or do the exact same math. As I said, usually the math is the easy part, right? It's a picture is the challenge. And if you do that one, you get 22.3. And there's our two answers. Okay, so to recap, in this question here, or in any question involving two compasses, you have to find that z. And there's going to be a z somewhere because two compasses are always, always, always parallel to each other. And sometimes you're going to have to use bearings from 180, or sorry, from 0, or sometimes you're going to use cardinal directions like we did in this case. If you do have two compasses, it means you're using the sine law instead of the cosine law, but the ideas of the trigonometry all still apply. Okay, I have 3 questions for homework for you guys. Just to practice a little bit here. One of them is a double compass. I believe it's number 8, so that's a tricky one. Try them. If you're stuck, come see me, and we can sit down and figure them out together.